Okay, let's continue graphing quadratics starting in root form. So we're going to start with something similar to the problem we finished with in the last video. Y equals 4x squared plus 5x. Now this is actually not in root form. We would consider this starting in standard form since we have ax squared plus bx plus c, and the plus c, since it's not there, would just be plus 0. So what we can do to turn it into root form is we factor it. Now, how do we factor without a c, without a constant term here? Well, it's very simple. We have an x in both of these terms, so we can just factor out an x of both of those. So factoring out an x, we'll get y equals x times 4x plus 5. And now we're in root form because now we can very easily see what we need to make x equal to in order to get y equal to 0. We could make this x equal to 0, which would be 0 times something equals 0. Or we could make this whole term equal to 0, in which case x would be negative 5 over 4. So those are our two roots. Zero and negative 5 over 4. Okay, so now to find the vertex. Now in this case, you can see that the x-coordinate of the vertex is going to be between the two roots of 0 and negative 5 over 4. That's going to be a weird fraction. So if we were to substitute that back into this original equation, or even this equation, we're substituting in a fraction for several x's or an x squared. So that might actually be a little trickier than just finding it the other way, which is to just take the standard form and complete the square. So let's do that instead. So instead of calculating the x-coordinate of the vertex and then plugging that back into the equation, we're just going to complete the square here. So what we do is we factor out a 4. Factor out a 4 from the first two terms here. Then we take half of 5 over 4, which is going to be 5 over 8. Squared minus this squared minus 25 over 64. Okay, and now we're just going to multiply negative 25 over 64 by the 4 to bring it outside of the parentheses. We'll get negative 100 over 64, which we can simplify to, let's see, divide that by 2, the top and bottom. 100 over 64 would be 50 over 32. If we divide that by 2 again, we'll get 25 over 16. So minus 25 over 16. And there's our vertex. Negative 5 over 8, negative 25 over 16. So this is kind of a weird, these are really strange fractions. So we can just approximate this. Negative 5 over 8 is about negative 1/2, and negative 25 over 16 is about negative 1.5. So let's just plot negative 1/2, negative 1 1/2. It's going to be right about there. Now, before we draw our graph, it might be a good idea here to just plug in some other points, mainly because the 3 points we're starting with here are so close together we can't really get a good idea of how steep this graph is going to be. So let's just pick an easy point to plug into the original equation. How about, since we have x equals 0, let's see what happens when x equals 1. Well, when x equals 1, we'll get y equals 4 times 1 squared plus 5 times 1. So that's 4 plus 5 is 9. So when x equals 1, y equals 9. And just by plotting that 1 point, we can now see that this graph is extremely steep, because we're going all the way up to 9, moving over by just 1x. And of course, we can reflect this point in the other direction. But since the x-coordinate of the vertex is a fraction, the axis of symmetry is not on an integer number for the x value, so it would be hard to reflect over this point exactly. So we don't necessarily have to reflect it over. Just kind of draw a mirror image like that. And that's going to be about what our graph looks like. Okay, let's do another one starting in standard form. So when you're starting in standard form, you can find the vertex first if you'd like by completing the square, but what we're going to do is use root form here. So in order to find root form, we factor it. So let's factor this. First thing we'll do is we'll take out a negative from the whole thing. And now we will have two numbers that multiply to -4 and add to 3. That's going to be 4 and -1. So here, this negative out here actually does not do anything in terms of what the roots are. It will change the graph a different way, as we'll see when we graph it, but the roots are just determined, again, by what we need to make x in order to get either of these terms to be 0, because -0 will still be 0. So we could have x equal to -4 or +1. So those are our roots. Okay, now let's find the vertex. So here we can see it a little more easily, that the vertex, the x-coordinate of the vertex right between these two roots of -4 and 1 will be -3/2 right here. So now we can just plug in x equals -3/2 into any of these three equations where we have y equals something, some terms with x in it. So this factored form might actually be the easiest to plug in for. So we know the vertex is going to be -3/2 and then something for y. So y will be, using this equation right here, negative x of -3/2 plus 4. That's going to be +5/2 times x of -3/2 minus 1 is -5/2. So here we have 25/4 with two negatives. Negative times negative will be positive, so this is +25/4 is the y-coordinate of the vertex. So vertex is -3/2, +25/4, which is just above 6, so right about there. Now what do you see with this one? You see that the parabola is going to point downward. And the reason for that is because of this negative out in front. The negative in front of the x squared here, the negative in front of both of these terms in the factored form. So when you have a negative coefficient of x squared in the standard form, that means that the parabola is opening downward, and that is true for all quadratic equations. Or if when you factor it into its two roots, there's a negative out in front, that means the same thing, that it takes the whole y value, and what it's actually doing is reflecting everything over the x-axis. A positive y value will become a negative y value, and vice versa. So the whole graph flips upside down, meaning that it points downward. That's what the negative in front of everything does to the graph. So here we have another thing that is in standard form. We're going to have to convert to root form. So if we try to factor this, we need two numbers that multiply to 9 and add to 7. So numbers that multiply to 9 would be 9 and 1. That would be 10 or 8 if we would use negatives or something of that sort. Then we have 3 and 3. That would just make 6. So we look at this, and after a while we realize that this cannot be factored. So we have to go to one of our two other methods for solving quadratics, either completing the square or the quadratic formula. So let's choose completing the square because it's actually going to be faster in this case, and I'll explain why after we do it. So we take x minus half of this squared minus this squared. And now let's just convert this 9 to a fraction with the denominator of 4 now to save us time later. So we'll get 36 over 4. Now just simplify this. And we get a vertex of 7 over 2 negative 13 over 4. So why was this faster than using the quadratic formula? Well, that's because the quadratic formula would only give us the solutions for x, the solution for x for the vertex. Then we would have to plug that number back in to find the y value, because what we didn't actually solve this equation here for x. We just converted it into vertex form. We know what that once we're in the form x minus b squared plus c, we have the x and y coordinates of the vertex here. So with the quadratic formula, you'd have to solve the whole thing first for x and then plug back in for y. So when you can't factor in order to get into root form, completing the square is going to be faster than the quadratic formula, just like we did here. So now all we have to do is plot the vertex. 7 over 2, negative 13 over 4. Think of what whole number is this closest to? Well, negative 12 over 4 is negative 3, so this is going to be just below negative 3. Right there. So now you might be thinking, well, okay, so we found the vertex easily using completing the square, but don't we still need to solve for x when y equals 0 in order to get the roots? Well, we actually don't even need the roots in this one. So technically, we're not even going to be using root form here. There is another thing we can find, a point we can find very easily that will allow us to graph without the roots, just using this vertex. And that is the y-intercept. So the roots are where the graph crosses the x-axis. But what about where the graph crosses the y-axis? Well, on the y-axis, we know that x equals 0. So if we substitute that back into this original equation, x equals 0, this is very easy because we have 0 squared minus 7 times 0 plus 9. All the x's are gone because they're all being multiplied by 0. 0 squared and times 0. So this is all gone. So we just have y equals 9. When x equals 0, y equals 9. And now what we can do at this point is reflect it over. In this case, it might be helpful to draw in the axis of symmetry going through the vertex. Axis of symmetry being on x equals 7 over 2. So we can see that it's 3.5 points away from the y-intercept. So let's reflect this over the axis of symmetry. 3.5 points the other way brings us right over there. And now there's our parabola.